Chaitanya. I've been programming in Erlang since 2003, so it's almost 20 years. I know mostly Erlang. I've been, I got in touch with Elixir 6 years back, and then I've been just trying out here and there. But I don't have a proper experience or expertise in Elixir. But I do have a good amount of experience on Erlang. Um, yeah. So this talk is primarily about what I learned about how to create clusters and using Erlang. And uh, let me give a background of what are the products I kind of developed in the past. So it's been 20 years. 2003, we started with, for 10 years, I did pure telecom, all the telecom based solutions, telecom based value added services, and things like that. So from the very first product, it's always about cluster. It's always about, 2, 3 nodes being there, and then a grid which is connecting, geographically 20, 30 countries together into forming one network and working there in Africa and Middle East. That was the very first project. After that, every project that we ever did was always, a very high performance clustered solutions. So they've been an evolution of cluster implementation since that time. What I'm going to discuss is what I found previous clusters, the architecture of that, and the new cluster, how the architecture is right now. So I'll give my 2 cents about what worked for me as an OTP application cluster and the design of it and what actually works in a way. I hope this is pretty, high level. So it should work for the same for Elixir as well. Any questions? You can
Yes.
interrupt me any point of time.
Yeah.
So there's an out-of-box OTP high availability which Erlang actually gives you, which is pretty simple. Like you get an OTP application. You usually have a load balancer or a kind of Nginx reverse proxy, any of those things which is front ending the cluster. Then normally you have a secondary node where the application isn't started. It's there in a state where the node is started, but application is just as a standby. And there's a heartbeat going on between these two Erlang nodes. And if it checks out that the one of the primary node went down, it automatically starts this application tree completely, and then it starts being live. It's up to the load balancer to shift from there to here because it can't see these application nodes, so it starts connecting to that. And more or less you will see that the mnesia or the state replicated. That's not provided with OTP, but you have to do it into your code. And usually this works as a hot standby. In any case, if this thing comes back, this one seizes the control and the application starts over here. So there's a dedicated, this is a primary node and this is a secondary hot standby node. This is how the design is. It seizes the control the moment it sees that the primary node is stopped. And this can be done using the Erlang OTP's release management. It's pretty much hard baked into the OTP itself. But there are issues in this, that it really is not an active, and there is a lag between one going down, the other one coming up. And when you have to bring this up again, you have to make sure that you only do it at offload times, because again this one seizes the control and gives it to you, so it will be a lag of few minutes here there. So this is not really practical in a lot of situations. In a very simple situation, yeah, it works out. Not so much though for regular things. So right now, what we kind of do is that it's a dynamic OTP cluster. That means that there is single node. You can always run as a single node. The application here, the application tree or the OTP and the supervisors and everything gets started as if it's not aware of any distributedness. So none of the things are aware of any distributed. They all work isolated as a single node. with its mnesia as its state and things there. And when we add a second node, the second node then is told that this is one of the node in the cluster. Then what it does is that it automatically connects to the mnesia and then syncs up the tables and the structure and everything, and then brings up the node to its state and starts the application again. And it is completely not aware of this nodes running here, because the cluster is again kept inside the niche's replication only. Although the nodes can ping each other, the application tree doesn't really care about there is other node running or not. They are running isolated to each other. What makes them binded is the replicated state in this niche. So if any process here is trying to manipulate a particular chat, if a request lands here, it does a statement management here. At the same time, if the second chat message comes over here, for example, then this one manages the thing. But it's a niche which manages the transactions and ensures that it's all properly maintained in a thread safe way. So this way, you can add another node to it too, and then you can keep on scaling horizontally. But there is an issue. Nisha is an ACID database. It's not really a CAP theorem, NoSQL. So the number of Nisha nodes growing beyond 10 is an overhead. So more or less, our solutions, these ones cannot. I mean, we practically don't scale it more than 4. We tie up to 4. So what we do in Insight is that we actually use a moderately powerful node for each of this cluster node. Any questions?
Uh, so are you saying all the four nodes must be started at once, or we can add one anytime and amnesia is going to copy all the data?
Yes, anytime you can start. That's the thing about dynamic thing. You can add, you can remove. It all happens uh, automatically.
Uh, uh, a dumb question, but like how large the amnesia database can be?
Um, Normally we don't use amnesia database as a I use it as a complete standalone main database for the whole solution. But normally people do not use it so much, but instead it's more or less used as a state management for all the processes that are running inside. Instead of putting into the Genserver state, put it into the Nicia. That way, the Genserver in each of the node is aware of is completely updated with the current state of it. So if you take that kind of situation, they're practically hardly about few megabytes. But the ones which we
Okay.
used, and now is almost 40 gig, 40 to 50 gig. So you can
Yeah,
grow to that point also.
A quick question,
40
Chaitanya.
gig.
Yeah.
So in this situation where we have three nodes and all of them are sharing the amnesia, single amnesia database, or the amnesia of each node is synced with the other nodes?
They form the cluster. So yeah, it's real
Okay.
time replication between every node.
Oh,
So
nice.
if you happen to write into one,
Hmm.
it'll go and ensure that it's written in every other copy.
Okay. So this is why we are able to use this instead of the gen server to store state across the
Yes,
cluster.
yes,
Okay.
yes.
Okay. Thanks.
And Nisha gives you a flexibility whether you want to make it dirty, sync dirty, or async dirty, or transaction or sync transaction. There are different levels of safe replication that you can do.
Gotcha.
You can do a combination of a lot of them actually. In some tables, you will have local content. That means that there is a process that is only there to manage its own state. Then it's a local content for it. Although the structure is the same across all the nodes, that also is.
Understood.
But this gave us a lot of ease in a way that somebody who is building this application need not even care about what nodes, where it is running. He
Mhm.
need not tailor his use case to a distributed thing. He's tailoring his use case limited to his in isolated instance.
Okay.
So that makes the development of individual components or the applications becomes pretty much easy.
Mhm.
If you are context aware of the nodes, and you are now managing the nodes in the application layer of it, then it becomes a little tricky in in sustained development of the solution.
Gotcha. So is it right to say that until you really need other solution for state management, it is a good practice to rely on mnesia when you're talking about a cluster because it will help you get started quickly?
Yes, yes.
Okay.
Not just get us started quickly. Last few products which are still running are doing about huge business of handling 500,000 calls a day. It
Oh,
still runs in this model. It doesn't have any other database except Nisha.
very nice.
Yeah,
So
it's
we
an
should learn
understatement
more.
to say that it's just a startup. It's actually works fully if you maintain the sanity of the design.
Okay. So I have to admit, I only looked at its, but not amnesia. So now I must spend time and understand it.
Yeah,
Yeah, we got a new topic for the next meetup also.
Yes.
Amnesia.
I
it's a very very good database for a small and medium sized solutions. Almost going till 1000 TPS things.
Uh, just
What was
a
that?
quick question
1000
that I have.
EPS?
Transactions per second.
Okay.
About 1000. And that's one of the things that we did is called message broker, where all the content, in the mobile network, there are all these content providers who keep pushing the content to all the handsets. It was a decade ago solution though. Now nobody pushes content anyway. But there are a lot of content providers connect to the system and then they push the content. So there was an integration broker which was sitting there, and it was bombarding messages from the content providers to the mobile handsets, getting the feedback from them and doing the billing as well. That system was doing around 1000 transactions per second, 1000 messages per second, and that was using just two nodes with Nisha.
oh,
Oh. And if we had third one,
Yeah, that's okay. I mean, it'll hand another 500, but it won't be that linear because now we have to maintain the three consistency of three nodes, so it will be around 1400 or something like
okay.
I had a question.
Okay.
So,
I have I have a question.
that.
Uh, I
But
wanted to
again,
ask the
one thing I want to tell you is that you don't have to bind the thing that Nisha, you should use it fully. But imagine if you're just taking out the state of the Genserver and putting to Nisha, that's going to be very minute. So
Yes.
scaling that across is absolutely not a problem.
Yeah.
uh,
Yeah, yeah, proceed.
I did not understand it. Can you please repeat the last part? The Gen server and amnesia part.
Okay, I'll show you the demo. Let me show you the demo of this.
Okay.
I'll show you the code and I'll explain the things in it. Yeah, I'll. Any other question that you have? I come back.
I have a question.
Yeah.
When we say that these nodes communicate with each other and the state, like the amnesia state, syncs automatically, I wanted to know that how does these nodes communicate? Like, is it over TCP or what protocol does they use?
Um, any I'm using basically the Erlang's in native distributed communication. The way that distributed nodes in Erlang communicate is each node actually establishes a TCP connection to every other node. So it forms like a grid network here. So this node is connected over TCP socket to this and also to this, and this one is connected to this and this, and it binds the TCP connection, and then they keep exchanging messages in the TCP connection.
Okay, so the connection is left open.
Yes, yes, always.
Okay. And one more question. Uh, this amnesia, we say that it's automatically syncing. So this behavior is only for amnesia, right? We don't get it for Genserver state or ETS. We'll have to manually sync it
Yes, yes,
across the
yes.
cluster. Okay.
In Nisha, you only have to set the setting to Nisha telling that, this is gonna be the node, one of the node to your cluster. You only have to tell Nisha once. Then it just remembers it and says that, okay, I have another node there for me.
Okay.
After that, you can now access the table. Now the table, need not be a replica in every node. Even if you have table here and these two don't have the replica, they still do as though they are working locally. The Nisha talks to this Nisha and then gets the table data and then gives to you. It's so transparent there.
Okay.
Hmm.
So, one question that I have is that you've heard of Fly.io, right?
Not really. Can you explain that?
Acha, acha. So, like just to give a two-line gist, what they do is so we give them a Docker file and they run our apps. So basically Amazon,
Okay.
but like AWS. But the difference is that if a requests come from say Singapore and I've deployed it in Chennai, but I've configured that whenever a request comes, they move the app to Singapore and boot it up there. So
Okay.
then my app is running in two regions. So same
Okay.
copy. So two
Okay.
local copies. So if so until now I was using Postgres and they had some mechanism to use the common Postgres, but the database times are different for both apps because the database is a single database located somewhere, but
Hmm.
the applications are running at uh, two regions. So
Okay.
my question is that if I use Amnesia instead of Postgres, my Amnesia would also be synced in two regions. Is that understanding correct?
If you do that, yes. But does it help you? Does it
Okay,
solve the problem for you? I doubt that. The,
because
the
my latency would be better, no?
it will be better, sure, for sure. If you have a lot of read access and less of a write into the database, then this model actually helps you much better. But you have, a proper ratio of write and read as well. Every write has to sync to all the nodes of Nisha. Then you are actually getting latency, large latency, because this Nisha has to send every request, synchronously to the other Nisha and then get written there, and then it will release the thing saying that, okay, this is getting written. So this kind of
Acha,
Nisha replication across geographies, I won't suggest doing that, because this is a
acha,
synchronous replication. It's not an asynchronous replication.
acha. I see, I see.
But if you have a few
So,
writes and a lot of reads, then it makes sense to
hmm,
do niche, because it's hardly going to be few of them. And then read gets a lot of benefit because it's very, very low latency at that node.
Hmm.
so just to guess around the number, what would a number be? Just to say that if I'm distributing across geographies and say this number of writes per second is a you know breakpoint where
Um,
I should think.
I don't know that actually, but I won't even
Acha,
go there.
okay.
Another reason is that Nisha is not very
Uh-huh.
good at network partitioning. If
Oh,
you
oh,
if you
okay.
you know if network partitions between them, then there is a mechanism that you have to employ to rebuild this thing again. It's a bit tricky. Nisha is not built for network partitioning very well, so
Hmm.
I would not suggest doing the geographical part.
Acha. The network
The
partition
most
is
yeah,
like headache.
yeah.
Uh,
Right,
okay,
Abhishek.
so
So,
if I
yeah.
have four servers in India itself, will Amnesia be good for in four different places in India or one
I No, no, I wouldn't suggest
office in
that.
India?
No, It won't. One office in India, yes. They all has to be co-located.
Okay.
This doesn't solve your geographical redundancy or geographical distribution. This solves the redundancy and high performance in a given cluster.
Okay.
Understood. Understood. This is much clearer now.
Abhishek, just a follow
Yeah.
up to what you asked now. The way I understood how Fly.io works with the distributed access is they spin up the VMs, the apps in different geographical regions, but the databases themselves are local. In other words, they have like a Postgres database located in Singapore and one from whichever is your main location. And from what I understand, they use a process to get the log files from Postgres, the write ahead log from Postgres, and then send the diff to the remote database to write on it so that the data is in sync. Does it
Do
make
they
sense?
do that for database also? I was
Yes,
not
they do it
aware.
for database. I'm talking about Postgres. That's what they do it for Postgres.
Hmm. Okay, so they keep that in sync. Do you say that
Yes.
like?
Yes.
Okay, I
Any
was not
geographical
aware.
redundancy across geographical areas, async replication is the mechanism. You cannot use a synchronous replication unless you have a dark fiber connection between this location to that.
Ah.
I had one more
Because
question.
there always will be network partition, right?
Yeah. There'll always be.
Hmm.
Arpan had a
Yes.
question.
Mhm. I had a question. So for this amnesia, I see that it's an in-memory database. So and it's
It's
limited
not
by.
just in memory.
Okay, okay, I see.
As I said, I used it to store data of entire, 1 year
There
of
are two
calls.
types. Yes, there
Okay,
are two types of ATS and DATS.
We don't use DATS. DATS has a limitation of 4 gigs per
Uh,
64-bit machine and 2 gigs per 32-bit machine. What I use is that I attach a rocksdb as a backend to the mnesia and use that as my disk only tables.
hmm.
okay. So it actually writes to the disk, right?
Yeah. And again, not everything. I mean, I use disk copies for most of the persistent tables, which I also need very good read access. And every node of mine is at least 32 gig of memory, so that it can actually load so much in the memory. But anything else, like archives, CDRs or history or reporting data, of detailed reporting data, they all sit in rocksdb. And Nisha has this thing where you can add backends to it. You can add rocksdb as a backend. You can add leveldb as a backend. You can also add Postgres as a backend to the Nisha. But I don't have practical experience with Postgres backend. But I use rocksdb. It's pretty stable and it works. Replication also works very nicely.
And can we configure that which part of the data we want to keep in memory and which one?
Oh
What is the part?
yes,
Okay,
yes, very much.
I see.
You
There's so
mentioned
much you can do
rocksdb
actually.
and leveldb.
Yeah, I use rocksdb. I used to use leveldb. Then when rocksdb was added to that the list, I started using rocksdb. Rocksdb is much better than leveldb. It's the same team who you worked on leveldb worked on rocksdb to integrate.
Okay. Which one is open source?
All of them are open source.
Cool.
Oh, this is turning out to be a great talk. Thank you.
Yeah,
Thank
thanks.
you. Yes.
Wait, I'll show the demo. Okay.
Like they say, movie is still pending. Picture bhi baki hai mere dost.
Yes. We also have Vamsi. He won't understand Hindi.
Hey,
Uh,
Vamsi, how are you doing?
Hi, Chaitanya, I'm doing great.
Long time, man.
Yeah.
You know, I mean, we know each other for a very long time, actually.
Oh, you?
Yeah, it's
Yeah.
been more than 8-9 years. Yeah.
Oh,
So where are you based from, say?
interesting.
Right now I'm in Boston.
Oh, you're in Boston. I'm in Connecticut, so we are neighbors now.
Yeah.
Okay, guys, you have to tell me whether you
Yeah,
can
we can see the
actually.
screen.
I mean, is
And
that okay, or should
requested
I
to
actually?
please increase the font size.
Yes,
Yeah,
please.
is this okay?
Yeah, much better.
Okay. Okay. The few things I'll explain in this is if you are not very familiar with Erlang, bear with me. uh, Normally, I have this API separated out, and then there's a base which has utilities and supervisor. This is my main application supervisor, my application behavior, and followed by the supervisor behavior. The supervisor behavior. Okay, before I do this, let me actually show you something else. Stop sharing. Okay. Let us just share. Okay. Can you see this actually?
Uh, yes, it's just starting up.
Loading,
Yeah.
yeah.
Okay. Whenever we have a project to start with Erlang, there are certain design things that we do, right? The prime thing that we often do is we first sit and frame the whole supervisor tree and see where we have what workers and what supervisors and how we actually put the things in. So let me explain some of the things. We need a interface to mnesia, which is a worker module. We need a module to in a worker module to handle the configurations, loading the configurations, updating the configurations, or exposing the APIs for the configurations to the web, things like that. We then have something called interface supervisor, which is the one which has adapters in it, which connects to the different. This is the north facing external connectivity to other external things other than the node. So each one has a supervisor of its own. If you look at it, there's a pattern here. There's a manager, and then there's a simple one-for-one supervisor, and then a bus interface. So there's gonna be many bus interfaces based on how many buses we are connecting to. So this is a worker module. This is a proper one-for-one, one-for-all supervisor, and this will once this supervisor starts this, and this a simple one-for-one supervisor, and here it gonna check in the database about what are the buses are there, and then it starts adding into this simple one-for-one supervisor as it workers to it. So that way this it's gonna be like a dynamic children getting added to this. And the same with this RTP interface as well. There's an RTP manager as a worker which starts. Then there's a simple one-for-one supervisor, which this one goes and keeps adding the children to it. This is a web interface that just simply talks to is a configuration for the cowboy. I'm giving this is that this is very important for before we start coding to see how do you going to serve it. So you we always had this multi-tenancy model. So in the multi-tenancy, there is a tenant manager, it's a proper worker. Then there's a tenant's simple one-for-one supervisor. The manager then goes gets all the tenants from the database and then keeps creating multiple supervisors of tenants under this simple one-for-one supervisor. So each supervisor of the tenant has a dynamic this SOFO has a dynamic child of the supervisor getting added to this, while this supervisor again has a manager for every virtual queue agent, and each one has a simple one-for-one supervisor to add the dynamic children, and for different use cases of it. anyone who is going to build big massive systems, it's very important that you have this kind of structure before you proceed coding, to do a have a how you can scale out and scale up and things.
I doubt, do we have GenFSM in Elixir?
Oh, okay. This is about 7 or 8 years old. GenFSM has been renamed as Genstate with a new more features in it.
Okay, okay.
Although this one is talking about FSM, almost everything is actually a Genserver.
Oh, yeah. The new name is Genstate.
Statem.
Statum. Change statum.
It's much better replacement for FSM. FSM had issues, so I actually implemented FSM in actual Gen servers. So we're actually using Gen servers then. Now, if I had to do that, I will use Gen Statem.
Cool.
Okay. Let me show you the code now. Okay. Here you can see all the supervisors and okay. Let me wait until it presents. You guys can see that, right?
Yes.
Okay. Now I wanted to show you is the transactions of it. This is the one which actually talks to Janus and it has a publishers to it. But if you look at the state of it, the init has only the stream ID and the meeting ID in it, nothing else. So this doesn't have the state of the calls or state of the things or the current transactions. Where do they all have? Where are they all in? You can see them in here. So this is the thing I put into the mnesia database. I have a third party which I wrote some time ago, which is called Tivan. I use that to interface with Mnesia. I don't use Mnesia directly because Mnesia uses records, and records are very restrictive for me for being to make it to scale up or feature wise or to be dynamic. Record seems to make my life tougher. So what I did was I wrote a module on top of Mnesia, and from that module I only interact with maps. So even the table definitions I give it as a maps. So what are the things that I need? And if you look at it, the whole of this table is in Mnesia. The whole transactions, everything is in Mnesia. The Gen server actually don't have any state there in the transactions part of it. I think I answered one of the question.
Chaitanya, I have a question.
Yeah.
Earlier you showed that supervision tree that one should try to visualize before they are trying
Yes.
to do something.
Yeah.
So should we make it by hand and understand key what are we trying to do, or is there some other way to do this?
I mean, a kind of a tooling.
I mean, once we write the application, we can see the supervision tree and everything. But
Yeah.
before we try to do it by hand, that's what you're trying to say, right?
Yes. It makes a lot of sense to sit and have a discussion with the team about how you're going to handle the use cases.
Okay.
It's very important to get the the flow of it properly designed so that it can scale. The supervisor tree that I showed you before, I can now add as many tenants dynamically as I can, right?
So then my question is like, why should I use supervisors at all? I should always use dynamic supervisors, so that I can
Not
add.
always. Actually, okay, let me again show you that. The problem with my screen is 44 inch. If I really show my screen, you'll never see anything.
Okay.
Okay, here if you see, this is a dynamic supervisor, but this isn't. The tenant soup isn't, because it has a very, very standard child.
Uh-huh. Okay.
It child not going to change. There's a difference between this. Under a dynamic tenant supervisor, you have a not so dynamic supervisor which has a very straight six permanent children, which always has to run.
Mm.
But
So
then,
this is your tenant, actually, how you describe a tenant. And this is the one which actually holds multiple of those tenants, and then this is the one responsible to restart if any tenant goes down. And
yes,
this is has to be dynamic, right?
but it doesn't harm to make a tenant also dynamic, right? It doesn't harm.
Uh, inside the tenant, but why do you see? I know very clearly that I need these children. Why do I make it dynamic?
I why why, because I think I'm thinking from a perspective of a startup. So let's say, a lot of things are evolving, and we come up with a tree, and then we decide ki nahi yaar, this is something or else. I mean, there are two more things that we want to do. So then I'm thinking that probably it's a good idea to do everything as a dynamic supervisor, because I don't know what requirements will change tomorrow.
Um, think about this. This is
Uh-huh.
when we designed it.
Uh-huh.
Okay.
Uh-huh.
Once we started developing it, there are about
Uh-huh.
8 more which added to this.
Mm-hmm.
You can still add them in the future
Mm-hmm.
to add more, things in this and then do. But the more primary importance here is that
Mm-hmm.
you have to have a s- a how do I put this? Um, Too much of generalizing a thing, stating that I can now in the future add anything dynamically without actually
Mm-hmm.
bothering about what it is,
Yeah, yeah.
will not give you so much of, like, performance, or in terms of understanding the, how do you want to manage the use case or the structure of it. You have to strike a balance between how much you want to have a dynamic thing and how much you want to have a packed structure.
I tend to agree because for certain things we know the amount of work that needs to be done, and accordingly we have the
Yeah.
code slash workers already set in stone, right? And
Yes.
based on that thinking, that unit could be dynamically started, which is what is reflected in the map you're showing.
Yes. Yes.
Ah, I see. So at some level, I should, decide that this is frozen. This, small
Not really
supervision.
frozen. Not really frozen. You're getting it wrong. This doesn't mean that you can never scale up. You
Yep.
can
I mean,
always
yeah,
add things into this.
but not
Can I,
dynamic.
can I,
That's
can
all,
I?
right?
Yeah. So Abhishek, the way I am thinking about this is in our initial discussions, we come to a conclusion that at this stage, this setup makes sense and it can change based on the load. We might decide like, okay, instead of 4 children, we're going to run 6 in this one, and accordingly it will scale. But that will change based on the usage in the future.
I want to add a point here is that if the adding of more workers is based on a load or a scale,
Mhm.
then you definitely have to go for dynamic. But
Mm,
here it's future wise,
mm.
because each one of them is doing a different job
Ah,
entirely.
okay, okay. S- Got
This
Okay,
it.
is
okay. So,
features.
Yeah.
These are
so,
not
uh,
these are not doing the same job actually.
Okay.
so yeah, I mean, so that was my initial question, that if my features are not decided, then it doesn't make sense to add a dynamic. I mean, I should probably try to freeze a few features, and then, for dynamic part, I should leave the load thing, not the feature
If
thing.
you look at, not exactly, but look at this here. Um,
Uh-huh.
this is going to be a single gen server for entire tenant. I don't want it to
Yes,
do anything else. So having a
makes
single
sense.
worker for this makes sense. Even
Yes,
this
it does.
agent tomorrow, if I feel that this agent single Genserver is a bottleneck for me, then I will create something like this, say another dynamic supervisor underneath the supervisor, and then put a manager here to add this FSM agents under that supervisor. But for now,
Yes.
it's not doing much job there.
Yes.
So if it is a discrete feature, always keep it static. If it is the same one trying to do multiple, multiple things of it. If you look at here, it's it is a voice queue. You can have as many voice queues as you can. A tenant can have 5 voice queues, 6 voice queues, because each one is going to behave exactly the same. So there I have a dynamic supervisor to add more, voice queues,
So,
processors as it
okay.
scales.
Okay.
You have to differentiate between, is it a feature or is it a scale of the feature?
Scale of a problem. Yeah.
Yeah.
So that part I
You
was
want
not
more
understanding.
workers to do the same job, then you do dynamic. If you are actually having different jobs, use a static.
Cool. This sums up very nicely. Thank you for that.
I have a different question. So I see we are using supervisors here
Oh,
every
let me
time.
share again.
Uh, So I was wondering, I saw the strategy is one for all. So I was wondering that in actual use case, we know the supervisors are good at restarting things if they fail. So and given that the strategy is one for all, it will bring down the entire thing if something fails in the somewhere in the leaf nodes of the whole tree-like structure. So I was
True. Actually, this is wrong here. This has to be one for one. There's no point if one tenant dies to shut down all the tenants. You're correct. This is actually wrong. We later made it, in a proper way, but it's documented wrong way. But here it could make sense, because let's say if any one of this is dependent on another worker to be very sane, if any other worker goes down, I really want to refresh the whole tenant. It again depends on your use case, what exactly is the role of relation between each worker has in them. And in one of the current project, what I'm working on, we are using REST for all. And you very rarely use that. The thing is that in REST for all, if I use it here, the thing about REST for all, it's a very good strategy. And what happens is, if my voice queue goes down, it doesn't restart this processes, it will restart everything else from down there. It makes sense in a way how you laid down the dependencies of your children. If you laid down such a way that the least dependent one on the top and the more dependent as it goes down, you're starting up, the rest for all makes sense. If one of the mid child breaks up, you rather restart the dependent ones as well. So rest for all is a beautiful strategy there.
Yeah, this is great. And one more thing. I wanted to know that we have this saying in OTP that let it crash, and we have very fault tolerant applications. But in real production environments, how often does a application crash and actually the supervisor restarts it? And following up on that, like what are the reasons for crashing? Is it some logical error in the code, or some state got corrupted somehow? So yeah, that's my question.
Okay, the let it crash is highly misunderstood statement actually. Let it crash doesn't mean that you don't do any kind of fault tolerance. Let it crash simply means that you don't shield a, a- you know a kind of a logic with an unknown error. If you wrap a logic or a code with a exception handling, so that anything wrong that can happen, I will protect it, then that's wrong. You have to code such a way, you have to develop such a way that you think about all the possibilities of errors and write the proper handling of each of those errors, uh, embedded in the code and embedded in your logic and things like that. But you do not write the exception handling for unknown errors. You should never do that. That's a key part of it. So if let's say let's take one of the thing here. Let's take the supervisor here. Yeah, there's a bus, right? It's connecting to the bus. Now, when it connected to the bus connection can break in between, right? So what we tend to do is that, I mean, what if we there's one way to do it is that that this kind of connection gonna break. So what is the remedy for it? The one remedy for it is that let the connection break off. So you will let this particular process crash, and the supervisor software will immediately restart it. Then you're freshly connecting to it. In some situations, there is a temporary interruption that always happens. That doesn't mean that the state is gone. You can reconnect and continue with your existing state. In that case, you will code this such a way that you will handle that error which is there in the gen server and not let it crash, and then retry reconnecting to it, keeping the state as is. If this process of reconnection requires that the state has to be fresh, then you let it crash, and the simple one for one restarts it. Now, when you say let it crash, that means that you are allowing an unknown error to kill the process, and the supervisor is going to restart it. That way, you will know that there's something wrong with this unknown case. Then you will try to handle that unknown case. If that unknown case, you will know the case in a runtime. Okay, there's something going on with this unknown case. Let me handle it in a graceful manner to that. So when it says let it crash, that means that you should not do defensive programming. Do not always go about in the last case and say that if I get anything else, then I'll do some print statement and then I'll go back it. That's not a good idea. And idea is that that particular worker, if it is getting an unknown thing, let it crash and the supervisor restarts. And let's say if this unknown case is continuously coming to you, then obviously the supervisor exhausts his attempts and the supervisor stops itself, and this supervisor then try to start it, and this crash is propagated all the way up and the whole application crashes. But that's a good thing in a way that when you are testing this application and you are bombarding with the things, you're not going to silently face an error and then checking the logs what happened to this. You will know very well that okay, this one crashed.
I see. This makes total sense. Yeah. One quick thing for this. So about refreshing the state, and when we are restarting, when the supervisor restarts the gen server, so we lose the state. So if in case we don't want to lose the state, that is one area where we should catch some exception so that the state we can persist, right? Because if we restart, we'll lose the state. Is that correct?
That approach is not correct. The thing is, you shouldn't. That's a defensive programming, very, very, very clearly. The reason
Okay.
is that why are you stuck with the state? If the state is in most of the cases, in lot of cases, when is a continuous error coming to the thing and it's not able to handle, it might be a problem with the state as well.
Mhm. Okay.
So you can actually relinquish the state and then restart it. But if your state is very important, it shouldn't be in the gen server at all.
Right. Yeah.
You'd rather
Then
put it
it
into
should be.
mnesia or
So does this
Okay.
mean that we should not try in this try catch syntax in Elixir?
you
I
should.
mean,
You should, but
is it not
only
a
when
good
you know
practice?
that. Let's say, what my point is that whenever you do try catch,
Uh-huh.
you know exactly how this, in a different ways, this can go wrong. Handle those exactly cases. Do not actually catch it for every case universally.
Mhm.
Then you will silently see that it's not working.
Acha.
It's not working, but you'll never know it.
Yeah. So
I think
in my catch block there should be like 2-3 pattern matches
Yes.
for the 2-3 known error cases, but
Yes.
for unknown error cases I am still not handling it.
Yes. if you know that they're going to be completely unknown case, let's say you're giving a work to somebody, some other library, and you know very well that I don't really bother about whatever that guy is returning. My state isn't messed up, or my continuation of work isn't going to messed up. Then you put that thing and then log it out. It's purely
Yeah, yeah, yeah.
incidentally that particular logic how you're going to handle. But largely people discourage universally putting a defensive code everywhere.
Understood.
Just
Understood.
don't put defensive care in the defensive code in the first place. Trust me, I will never even have in a function clause. Even I don't even have a thing where it doesn't pattern match there. Then do something like error or something like that, or throw it into the log. I want it to fail, because if my understanding of the use case is wrong, and if I coded the cases of it, and if a third one comes in, I want it to crash and let me know. And I caught a lot of those things where my understanding was wrong about the use case in the testing phase of it. If you put a universal thing, you will go silently out. You will never understand that.
Sorry to
Yeah,
interrupt.
I think my takeaway from this is
Go ahead.
Go ahead. Yeah, I was just saying, Sandesh, I hope you're recording.
yeah, I was just
this.
saying that.
Yes, it is being recorded.
Yes.
Oh, perfect.
With permission, we are recording. Thank you for approving.
Thanks.
Yeah, he approved a recording, so I am able to.
Yes. A lot of good information here. I can't hold everything in my head. It would be nice to go back and listen to all the things we talked about.
Yeah, and I have thoughts about testing. Like, this is so wonderful, and my question is, how do we test this? Test cases.
That's a topic for another day.
Yeah, probably.
Okay.
I'm not really good at that, actually.
Okay.
Yeah.
Yeah, I mean, one thing I tell you is that in 20 years I've been coding Erlang. It will be just handful of them where I use try catch block. I know very sure that okay, this idiot third party will just fail always, but it's not very important to me. That's when I put this catch block. Otherwise, I always never use catch block, because I want my system to be deterministic the way I think it should work.
Makes sense. So, like, a lot of bad JavaScript habit was there. So I was doing try catch at a lot of places, and then one of my friends pointed out. So I'm like, okay, I should probably learn it, not to do it.
Yeah, it always comes with experience. Okay, anything else? I shall continue with the demo.
Yeah, please.
Okay. Demo is not going to be very difficult. It's just whatever I said, I'm just going to show that.
Yeah. If possible, can you please increase font size again a little, because it should appear clear in Leo. Some
Okay.
more. Is it
it
possible?
fine?
Yeah. Yeah.
Is it okay?
Yes.
Okay. So yeah, this Divan is the one which I wrote this particular thing. Yeah, we can discuss that later actually, where I actually define the tables in the structure that this third party which I wrote also handles foreign key references, which Nisha inherently doesn't have, and type checks as well. And yeah, this is where I say whether it has to persist or not. This is persist false, this is persist false, and I also have this getter setter functions. I put it so the entities module has all the structures and everything which goes and creates a table structure for me, and the transactions has all the running code with FSMs which are there in this. And APIs are the ones which which expose the I wrote a small module called Bifrost. It's not very good, but it did serve my purpose, where I defined the routes for each of the module. And yeah, I mean in Elixir, Phoenix is way better than anything. We don't have that in Erlang. And we have plugins config. Okay, Now let's do this thing. And I'm doing a big Docker. I use Docker to create my builds. So let me actually show that as well. This is my basic Docker to create a Docker instance. Very simple thing actually. So normally I do a Docker and it creates a Docker instance, Docker image, and then it publishes to my repository. Again, this is it does twice because actually in production what we did was in actual thing we did. This is a sample one anyway. It has a current 2 point version, and it also has a minor version pushed to it. So if you are if you push a minor version and then you want to pull the 2.0, it'll bring out the latest minor version from there. Okay. Let me list all. This is my virtual machine. I have a simple file. This is you can use Kubernetes if you want, but I wanted a simpler one, so I wrote my own shell script to manage my Docker instances. So yeah, do like ctl start in the Docker image. Okay, and I will let it into the console. So this is a console. If I do the mnesia info, this I'm talking about this mnesia replication. So currently it has just one node, and it's pretty much runs as if it's a single node. Here there's a backend rocksdb copies, and I right now not using any rocksdb copies, but I have a lot of rom cam copies and disk copies. Disk copies doesn't use DATS, so you don't have any limitation. RAM is your limitation in disk copies, in RAM copies in these two cases. Uh, and this is my
What
only node which is
what is
running. Yeah.
difference between disk copies and RAM copies?
Okay, RAM copies is that it'll just create the thing only in memory, and once you shut down the node, everything is lost. But your schema is disk copy here, so it'll retain the table structure, but it will not contain the table content. While the disk copies has a persistent copy and then the in-memory copy. So whenever you write into a RAM copy, it'll just write into the RAM. When you're reading from the RAM copy, it'll read from the RAM. If you are writing into a disk copy, it'll both write both into the disk and the RAM. So the write is a bit slowed, but it will be persistent. Like even though you shut down the node and bring it up, you still have the thing.
Okay.
And there's no limit here. Is a memory RAM is your limit for the disk copies. Even you can have what 6 GB or 10 GB file table as well. But mind you, when you are actually starting the nodes, Erlang will try to read from the disk and populate the RAM. So I wouldn't suggest having a very heavy tables in the disk copies.
Okay.
If you want to have permanent but not in the RAM, you are okay to slower reads. Use rocksdb copies. Okay, so now we have the niche cluster here. Now let's go to the second server. Let's name this now as Ubuntu node. Now we start the other node. Ubuntu. Okay. Here I want to show you one thing in the thing here. Okay, what is this? my CTL. If you look at here, the remote node, I mentioned it as Mighty1 at Ubuntu other. So we'll try to connect to that when it starts up. It can't connect it, so it'll fall back to standalone node. Okay, I'm here now. Mighty1 CTL. Let's do this now. Start. Trying to pull the image here too. This is my virtual machines on this box.
What is my T1? Any name con? What is it?
It's just my file, my bash script.
Okay.
But I put it into the user local bin because I could, I just put it there. So that's the reason it's able to. Okay, let me remove this niche out. So there's a my T1 CTL. Okay, my T1 CTL. Oh wait. Okay, there is a problem. Error while creating mount source point OTP var read-only file system. Although it's running in the Docker, I actually have. Let me do with sudo. Maybe it'll work. Hmm. What happened? Yeah, what happened here? Yeah. Okay. Is there any user that it's trying to mess? Always. No.
I have opened a pool for others.
Okay. Looks here though. It's fine. Okay. What happened here? Let me. Let's do something crazy. Right. Oh, this is a read-only file system. Okay. A read-only file system. Okay, let me try another one. Hmm. Any guys? Anybody has any clue what happened here?
Can we run the docker command as sudo?
I tried
Maybe.
that.
Okay,
I
we
tried
ran
this
that.
sudo.
Yeah, we ran the bash script in sudo. I guess that runs the docker as sudo as well,
Yeah,
right? Yeah.
it's saying that it's a read-only file system. Just give me a minute. Oh. Okay, let's. Okay, let's do one thing. This one is running anyway. Might be one. Um, and then Indonesia. It was running. Let's do one thing. Let's and kill. Okay, see this thing. Kill. This node here. Let's put that thing. No. Once. Okay. Okay. Nothing wrong with those VMs. Okay. Okay. I get the point. The problem here is that if you look at this, and then you have the mnesia info, it's still single node. Although I asked it to connect to the other node, it couldn't connect to it. So I know what the thing is. Stop. Um, uh, can I ping Ubuntu? No. That's PC hosts. I need to add into that. Okay. Uh, okay. 168, 122. Okay. Let's see. Yes. Okay. Now let's put mnesia info. Okay. Can I? Oh, okay, okay. I get it. I get it. I get it. Okay. Okay. Stop. The minus RF. All of them. Sure. Okay. Let's do the start. Soul. Ivan info is just a map into the mnesia info. Here it is. So now mnesia is automatically connected to that. If you look at the two nodes, both the nodes are active. Now the both niches are connected now. Although the applications are not aware that there is a cluster node, each one will be running on its own, and you can add another node and then connect it as well. All you need to do is just mention the one of the node in the cluster, and then this one will bind, the niche will bind to it, and then it'll connect to it.
Sorry, can you repeat how Nisha discovers another node?
It doesn't discover. We have to put the code in. Where did I do that? Is if you look at the Docker file, not the Docker file, the config scripts, one CTL, and in CTL. I put the remote node here, right? This is passed
Yeah.
to the Docker instance as one remote node. Okay, that is picked up by config RC, where it will pass this one remote node to Tibon as a remote node. Now, if you go to the where is this? No. No, build lib and in that, if you look at the mnesia, not mnesia, schema here, tries to get the environmental variable of remote node, and then it pings the remote node, and if it's able to ping, then it creates a cluster schema. And here all I had to do is this one. This is the key to connect one nation node to another. You have to ask the other node that please add this node as one of the cluster node. Once this one is done, then automatically the niches both will connect each other. Although this wrapper does all these things, in an elaborate schema, but if I have to show you a demo, I can do that too. Let's call it as first. Right. And then I do an initial start. You guys can see the screen, right?
Yep.
Yeah.
Do initial info. So this is the only node. So now let's create a table, some kind of a dummy table. Create table. Hello. And if I don't give any attributes, it by default creates an attributes. Table info. Let's say hello, and then I say I need an attributes value like this. So if I do the niche info, I have the niche hello table here. See it. Then if I do niche, let's add one record to it. Dirty right. Hello. This is the record structure of it. Let's give the key value name and probably my name. Okay. And if I do dirty read, and then I do hello, and then name. No. Yeah, name Chaitanya. Okay, name actually. Get the record. It's there. Okay. Simple table, one record in this. Hello has one record. Now let's start the second one. Put the cookie as Erlang. Now, exactly the way that the one module did, let's do the ping to first at new. Now if I do nodes here, I can actually see the other node connected. Now I'll start the mnesia. If I do the mnesia info, it's just a single node. Running DB nodes is that. Now if I do RPC call, wait a second, what did I do here? RPC call, remote node, mnesia, change config, extra DB nodes, right? Okay, remote node. Okay, is first step up node or the IO. Mnesia, change config. I think it's extra DB nodes. Now it's nodes. And then I mentioned the other node that I need. No. Yeah. Let's okay. Okay. Now let's do here and see if both the nodes are there. So yeah, both can understand that there are two copies of mnesia there. Now I don't have the table here. It's a remote copy. If you look at it, hello is only created here. It doesn't exist here. But it's the beauty of Erlang. I can read it. There it is. And if I want a local, I want the copy to be here so that it's local to me and it's fast for me. I can simply do add table copy. And what's the table I need? Hello in the current node. And I need it as a RAM copy. That's it. And
Wow.
and then if you see here, the hello comes here as a RAM copy. Now, if this one goes down for some reason, it understands that this is not there, but the hello is still here because I made a copy here.
Mhm.
Okay.
And what happens if the remote copy is updated? What happens to the RAM copy? Is it stale?
I'll show you. Let me read hello. It's still there, right?
Yeah.
Let's create another record here. Let me write hello phone. My phone number 1522600830. Right. Oh, sorry. Has to be a tuple. Okay. Now if I go to mnesia info, I see that it has two records. I usually have this, you can do this thing. Mnesia, okay. This comprehension, mnesia, dirty read, X, pipe, mnesia, dirty all keys. And then we say, what's the table? Hello, right? Okay, let's do this thing. P. Okay. And let's come out of this. Mnesia is fine. Okay, now all equal to one anonymous function. Pass key to this. And it's out. Somewhere there's a wrong thing. Oh, and still no.
Bracket missing the fun here.
Is it? Oh, this is one. Where it's missing?
So after fun T, the bracket is missing. There.
No, this is, yeah, that's fine. So if I say hello, I get aborted, bad type phone. Bad type phone. Oh, actually, I have to say this has T, X. Now if I do hello, oh no. I do all hello. Both the records are there here. Let's take the same thing. and apply it here. Okay, let me start this, and I'll start the mnesia. Okay, I'm applying this function here. No exists, hello.
There is no in this new node, right?
Are the nodes connected? Amnesia?
I think we have to connect.
Oh, it's not that problem actually. Okay, I get the problem. It's just that both are using the
Same name as remote?
same mnesia file system, I guess. Okay. Let me try again. Okay.
I think if I understand, first you started one server, then you opened the configuration file and renamed something, and started the second server. Is that?
No. That's okay. Okay. Actually, let me take it to some other path of it. Let's do it here. So let's do the first or second. First, actually. Let's do the first here. This is better actually. Okay. Now let's say mnesia start. The thing is, if you have to have a permanent structure to it, even though you're not storing any tables, you would have to create a schema. So mnesia create schema node. Okay. Now you need to do the same thing. Create schema in the current node. And then when you start the mnesia, and then you start the mnesia, and then you say idiom ping trusted node.io. Now let's take the RPC call. This is RPC call. Okay, let's do this thing. RPC. You can need not do RPC call. You can actually do mnesia change config if you can actually access the thing. It's the DB nodes and info. Actually, these nodes compatible schema. Okay, we do it another way. Info. Yeah, colon start. Change config. Extra DB nodes. Actually created my own library called Tivan, right? From then on, I'm not using this native base. Okay.
Okay.
Yeah, info. It still says the same. Okay. Net underscore ADM thing. Second at R. No, they go. Long. Extra DB nodes. Actually, I have to write this there. Okay. Issue info. Okay. Issue info. Here the schema is disk copies. Here the schema is RAM copies. Let's change that. Change table copy type schema in this current node as disk copies. Oh, node disk copy, change copy table type, botted bad arg schema unknown. Just give me a second, guys.
Do you do H and function name by any chance? We do it often in Elixir.
Which one? Erlang is very lagging behind in terms of tooling.
Okay.
Yeah, I mean, they enabled that in table
Yeah, this is
node.
OTP 25.
Yeah, it's there in table in that. Disk copies. Syntax is correct actually. Oh, sorry. Yeah. Okay. Now both are connected. Let's create a table here. Mnesia, create table, test. Let's call it test, and no attributes. Mnesia, 30 right. So test name. Let's keep it simple. Okay. Now in this, if I try to read, dirty read, test one name, get it. But if you look at the niche table info here, it's a remote copy. Okay. Let's add the table copy. Copy test the current node as RAM copies. Okay. Now if I do niche info, it's now the RAM copies. Now if I shut this one down and then 30 write test phone, and let's put that thing here. Oh, sorry, test. Test. There are two records here. Now let's start this one again. Let's start the niche. Now let me put this thing here and all. I'll put test. There, both are there. Although this was down when I was writing this, when it came up, it actually pulled out the changes and then did. Now let's shut this one down. And here, let me delete them. And let's say test. Let's delete the phone number. I don't want people calling me. And if I do all tests, it's not there. But when I start this, and then I do Nisha start, okay, and it's on. It always keeps in sync. You want to write, create another one here. Like let's put the phone number here. Let's say 007. Okay, now you find it here too. So this is how the state can be pretty much replicated between those two nodes, and your processors need not actually aware of another node or anything. They can simply keep on working and leave the distribution of the load to the load balancer above.
Yeah, this is great. Yeah.
Wow.
Yeah, at some point I'll explain, what this Divan does and all. It's a pretty massive system actually.
Yeah, we can invite you again in August.
One quick question. So adding a node would mean editing that Docker command to add something else to that environment variable, so that
Yes.
okay.
Yes. Yes. And yeah, that environmental label is given to Tivan. Tivan gives, I mean, it's initial, so you can write your own code. You need not have Tivan to, which can actually pick up this very thing and then do the change. Exactly the code that happens here.
Mhm.
Yeah, we'll do that. Yeah. Any questions?
Uh, the code you have shown us, I assume it is proprietary code of yours, or is it open source that we can visit anytime? Just
Um,
asking. The sample
one?
code that you shown.
Oh, the
Yeah,
supervisor trees and all that is
yeah.
proprietary, but this one is
Okay.
open source. Tivan is open source. You can pull it out and then see the code.
Uh, is Tivan a library or a app?
It's an app.
Okay,
It
it's
has
open source
servers
also.
too. Yeah, it has a server also where it does the serialization of the request. It does the uh, validations of it, and you can do update, get, put, and things like that. It
I
even does
assume it.
paginations and all these things too.
Okay, is it like your personal library or I'm sorry, I'm asking personal library or app
Yeah, I wrote
or
it. Yeah, I wrote it for me, but it's an open source thing. So if you want it, you can check it out.
Is
on
it kind
GitHub
of
or
web server, or
Sorry,
is it
sorry.
kind of web server like Cowboy
No,
or?
it's a layer on top of Mnesia to give me additional functionality. Which Mnesia, if I had to use it completely on plain known Mnesia, I had to write my code on top of that. I was writing that pieces of code everywhere. Then I thought, let me write a library and use that every time when I use Mnesia. This thing which I showed you, that the one which goes and connects to the other Mnesia, that's something we need to write the piece of code, right? That is written into this thing where you simply have to give the in environmental variable or thing, what is the remote node. This one will automatically connect to it and then pull out the schema and then does the thing. And every time you can actually change your table structure, and then whenever you apply that, it will do a dynamic transformation of the table based on the new table structure. Tivan does that, so I wrote my code for that. Isha exposes those things, but it's not completely, in full form. So what I tend to do is that here there's a create table. The create table actually does, finally when everything is done, it will do the post create function. And in the post create function, it wait for the table and it does a transform. If you have a new table structure, it will realign the indexes and change the attributes and things like that. So you can actually upgrade your table structures without actually having a downtime.
Okay, this is like a wrapper over amnesia, which
Yes, which
yeah.
gives me additional functionality.
Mhm.
You don't have to use this. You can write your own plain simple thing. If you're just maintaining your state in Nisha, then you have to write just a pieces of code here and there, and then it should work for you.
Okay, okay.
The basic thing about distributed Nisha is part of Nisha, but for you to dynamically connect this node whenever it starts up to the cluster, not whenever, the first time it starts up, instead of running manually all the commands like extra db nodes and things like that, I wrote a module to help me out with those things.
Uh, I had one question. So for the existing running nodes, how do we connect them to if there's a new node that we are spinning up, the existing nodes, they are not aware of them, and
Yeah,
how
yeah.
do we make them aware? Like can we edit the environment variable and they'll know automatically, something like that?
You don't have to say existing nodes, let them run as they are. You know that node name, right?
Mm-hmm.
For the new node, give one of the cluster members node. In Nisha, the thing is that if you connect to one node and then thing, it'll automatically connect to the rest of the nodes.
Okay. Yeah.
But you don't have to let this node is sufficient enough. If it's able to connect it, this node will it should automatically go ask the other node saying that please add me into this. That's where the RPC call is for.
Okay. So I don't need to connect a node to every other node in the
No.
cluster, right?
You just have to connect to one node, then you're part of the cluster.
Okay. Okay.
It's like a ring. You
Yeah.
just connect to the nearest adjacent one, and then you are known to all the cluster.
Yeah. This is powerful stuff. Yeah.
Super powerful.
Yeah. Like
Yeah.
I only have exposure to like these RDBMS. This makes me very much interested in how these amnesia works and how it fits in the like cap thing. And
Yeah. Amnesia is
I
very,
just,
very powerful. Yeah.
sorry to interrupt. I just wanted to check with Chaitanya. How are we on time from your end?
I'm done for the day, right?
No, yeah,
I'm
but
okay.
like you're comfortable continuing the talk?
Yeah, sure.
Yeah.
I mean,
we
you're
can-
not obliged to. When you let me know, then I'll then stop this
We are
thing.
okay. We just like uh, uh,
Oh
we don't
man, it went
want some disturb
went to
anymore.
1.5 hours actually.
Yes. Yeah, please continue your question. Someone was asking a question, right?
I have a question. Like,
Hmm.
I'm trying to do the same thing in Elixir, but I think I am missing some syntax or something like that. It gives me a function clause error when I try to do net ADM ping the another server. I don't
It
know
should
what is.
work actually because it's the same function. If you want to share your screen, you
I,
can show me that.
yeah, I will share my screen. Is it visible?
Coming up.
So these are two different directories,
Mm-hmm.
and I clear it and I say mnesia.start. Okay. So I
Yeah.
started amnesia on both of them,
Okay.
and then I say amnesia.create schema.
No, wait. You can only create schema when the Nisha is stopped.
Oh,
Or you can convert the existing schema to disk. That you can do. Let's do Nisha info. Let's see what's the schema right now.
amnesia info. So
It's a RAM-based schema, right?
yeah, it's a
Okay.
RAM-based schema.
Yeah,
This is
without you already started the thing, that's fine. What you do is that Nisha colon change table config, change
uh,
table type.
but uh, I'm like, should I connect first? I'm trying to connect, and that's where I'm.
Oh, okay. Well, yeah, first connect that. Net
So
ADM colon. I mean,
this
for
is
you
visible,
dot,
right?
right? Yeah.
So I say ping. It should autocomplete though. Yeah, it does, right? Ping.
Yeah.
Yeah. So I put this is test.
Wait a second. How is atoms written in Elixir? Is it still single quotes?
No, this
Atoms
is
are colon,
Uh,
right?
atoms are like this. These are atoms.
Ah, okay. Then it's an atom actually. The node name is an
Abhishek,
atom.
can you try?
Sorry.
Okay.
The node name is actually an atom. It's not a
Okay.
string.
Okay. So I should also write this minus something like that. But can
Yeah,
I
but
add?
it has special characters there. Does it take it? Oh,
you have to
I am confused. Let's see. Yeah, this is
Uh,
arithmetic
can you
wrap
error.
try
it
with
up in wrap
single
it up
quote,
in quotes.
and single quote?
Let's try single quotes. Should I remove this and single quotes? This?
try.
No,
This
single
one?
quotes will make it a char list. Just
Yeah, yeah.
yeah, just the colon followed by quotes, and the name should do. If the atom has space or in special characters, we wrap it in this. Yeah.
Not double quotes, I think. Is it double quotes? Okay,
Should
do
be
it.
double.
I don't know.
Yeah.
Yeah, maybe. Try. Yeah, there it is.
Oh, it connected. So that is what I was missing. So if I see amnesia.info,
You won't they see them binding. You have to tell them to connect.
sorry.
It's just a ping to the
It's
server.
just a ping
Oh,
that doesn't work. The
sorry,
niches are
sorry,
aware now. I mean, the Erlang nodes are aware of each other. Just do nodes.
sorry.
Just do nodes and see. You should see both
Okay.
the.
All right, all right. So this solves. I can proceed now on. Like
Yeah.
uh, I'll play around, and so this is enough for now. Thank you.
But remember one thing. Those are all still RAM schemas. The RAM schema, whenever you connect and then you stop and start, it doesn't understand the remote node because it doesn't have a setting. So make the schema disk based. Then do the change config and then add the remote node.
Got your point. Okay.
Yeah.
I'll take that. I'll take care of it.
Yeah.
Is there a
What book would you?
uh, uh, there's just one more question. Like, is there a good documentation on amnesia? Like I can read and it will be sort of clearer. Do I need
Yeah,
to
I mean,
break my head?
the
Erlang docs.
general,
And visit Erlang docs.
yeah,
They
Erlang docs is fine. But to have certain, introduction to that, learn do you have the Joe Armstrong's book, Programming Erlang?
No, I have not read it. I have the book, but I have not read it.
Yeah, it has a very good, introduction to Nisha.
yeah.
Okay, okay.
So that one, that learn some Erlang, learn you some Erlang.
Yeah, that's also good.
Yeah.
That's good if you know the philosophy behind it, and you want to just practice. Then learn you some good Erlang is good too.
Yeah.
Okay, so I'll start with the book and then I'll go to the blog. Thank you.
Yeah. There is one more
Okay.
also. Actually, I was going through some article. There was something else. Momento. I think there's a library in Elixir which works similar to this Divan thing. Actually,
Okay.
I think it's
Momentum.
Momento. Yeah. There is. I'll share that in the chat. Yeah. But primary philosophy for me for Divan is to do these ancillary things which I need to do, every code. And I want a map interface, not the records or any other way.
So I think map is mostly used in Erlang right now.
We are using more maps. Yeah.
Maps, yeah, more maps than records.
Yeah. Records, it's good for type checking and all, but it doesn't give you the dynamic, the problem
Okay.
with records is that if you have two modules sharing the same record structure, and if you update one module, it doesn't work. You have to update the other module also, which understands the same record structure if you're updating a record. But maps is
Uh,
backward compatible, upward compatible. Like if you add more elements to it, then it should work.
I was just wondering, React Core could also have been one of the option for you, as it is also open source. But
React core.
how React Core,
That's a front end, right?
React RIAK.
Oh, React. Okay.
Yes. Bit 365.
Yeah, see, the thing is that if I take any of those things like React Core or Redis or Mongo, any of those things, the only concern for me is that that's a third party system. Third party in sense it runs out of the space of my process. And it is a separate system I need to manage or I need to maintain, and the interface between that system and mine always makes my data serialized in and out. I want to
Okay.
avoid that actually, and then have Nisha is good in a way that it runs in the same user space as my processes, in the same Erlang world, in the same Erlang data structures. So for me to put the terms, Erlang terms in it, and then take the Erlang terms out of it is zero impedance for me.
And debugging also is easier.
Yeah, I mean, you need not use it as a complete database. I use it because I am very comfortable with it. I know how to make it work. But even though you don't use Nisha as actual database, you can still use React Core, Redis, or Couchbase, or any of those things. But to maintain the Genserver states, it's better you keep it into Nisha and then replicate across other nodes to have it more clustered way. At least the Genserver states. That's what I'm.
Okay.
A follow-up question on this. So, do you recommend that we only go with Nisha if we have like a distributed setup? If we have only one node, is Genserver state and ETS good enough?
Yeah, it's good enough actually.
Okay.
Unless you want it to, you want the process to crash, but you still want to have the state, then in that case, even in a single node, Nisha is better.
Okay.
You have to, I mean, in a way, if you want the state, then Nisha is a better way. Otherwise, keeping a process and then tying up and then writing a defensive code to make that process never crash because it's holding a state, then I would not suggest that. Use Nisha directly.
Yeah.
If Nisha has so many things, then why did ETS come into picture? Just
Oh,
wondering.
Nisha uses ETS. Where do you think all the RAM copies are?
I was beginning to wonder the same. So nice.
ETS is part of Nisha. It uses the RAM copies, all the RAM copies, all the disk copies, the RAM part of the disk copies, everything is ETS.
And
Nisha,
what is the remaining part of amnesia after we have ETS?
ETS is bound to a process. If you look at ETS, it's just, whoever process, which process has started the ETS table. If the process dies, ETS dies. Unless you hand over the process, that particular table ownership to some other process, then you can kill yourself. But if your process dies with an ETS to it, the ETS table is lost. That's one thing. Second thing, ETS doesn't do distributed. It doesn't know that there's other ETS table there. It doesn't maintain the distributed records. Nisha does that part on top of ETS. Nisha is a layer on top of ETS to provide you with a table which is not bound to any process that you create, which can do remote a transparent distributed characteristics, and it can do additional indexes and different types of tables. ETS can't do disk based. So Nisha has this disk copy where it can actually put the disk logs of everything what is there in the ETS to a compressed file, which can then be used to load to memory when the if when the node restarts.
Okay, I was thinking ETS is just like a database and there is only one ETS. And after speaking with you, I think I can have multiple ETS in one node as
Yeah,
multiple
yeah, yeah,
processes are calling.
yeah. But there's usually a cap of how many ETS tables you can create, but that can be
Uh,
overridden in your when you start your node.
no, not ETS tables, but ETS database. Can node have multiple ETS database?
What is ETS database then? I didn't understand that.
Maybe I am confused.
No. ETS means Erlang term storage. So term is your kind of map, or I mean, it's kind of a data type. So you can have
You
it.
can write your own Nisha
Yeah.
with the ETS. That's what
ETS.
you mean to say.
Okay. And
There is only ETS tables. And Nisha is a layer on top of ETS to give you this querying, distributedness, and all this stuff.
Okay.
okay.
And uh, as we discussed that with ETS we have this process owning the ETS table, and we always have this risk that if the process crashes we lose the table. So with with Nisha, the underlying ETS table will be owned by Nisha,
Nisha, yes, exactly.
and okay, and we are since it's managed by Nisha, so I think we are secure on that front, that it won't let the process crash and let our ETS get lost easily, right?
It's not in your user space, to be clear. The table is owned by somebody else and giving you access.
Mhm. Okay. Okay. And we don't access that ETS table directly. We use some Nisha
Nisha
wrappers over it.
functions, yes,
Yeah.
yes. You
Right.
can actually query using ETS also on Nisha if it's a RAM copy or a disk copy. Try that, it'll work actually. I'll
Okay.
show you that if you.
Okay. So for that we'll have to get ownership of the underlying ETS.
No, you don't have to. I'll show you that.
Okay.
Is there a concept of ETS tables can be public or they can be
Yes.
private? So
Yeah,
is
but
there a
Nisha, there's
Uh-huh.
no point actually having a private TTS. Misha might be having its own private TTS. We don't know, but if you are accessing from somewhere else, Nisha is giving you access. It's creating a table and giving you access. That directly means that it's a public, right?
public? Yeah, yeah. Okay.
So let's do this thing. Nisha start. Nisha create table. Test again. You don't need anything. Nisha 30 right test. Oh, let's put atom for now. Doesn't matter. Okay, now yes, there is a function here to app to list. Okay, let's do this thing. There. So test is actually an Nisha table, but it's also an ETS table, so you can actually use ETS
Wow.
functions on it too.
Okay. And where does the private and public table part comes in? I thought this was a private table that only Nisha can manage and we can't access it directly.
No, Nisha creates a public table.
Okay.
Even public ETS tables are bound to process. Although everybody can read, write, if the process dies, the ETS is removed off.
Okay.
But here in this case, the Nisha holds these public tables. Everybody can read and write.
Mhm. Okay.
So everyone in the world who create distributed app using Erlang, can I assume they use Amnesia?
No, not everyone. This is my
Okay, what
approach,
might
my way of actually dealing with these things.
okay, what might
Not
be
everybody uses
other
that.
okay, what might be other options people are using for distributed?
Um, okay, think about this way that let's say you do not want to store your Genserver states or anything you don't want to use Nisha. That's all okay. Maybe think about the architecture where there is a Postgres database and then there are microservices in the middle layer, and each Erlang microservice is isolated and runs as a Docker instance. And there is a front end which is a load balancer which is doing the things. Now these individual Docker instances work isolatedly. They don't even want to talk or know that the other Docker instance of the same type exists. They're all managed by Kubernetes to increase the number of those nodes or decrease the number of those nodes. And each one of them, the states, the way they work, are all connected to the Postgres database. That works. You
Okay,
don't have to use Nisha at all.
but that would not be as performant as this one.
It depends on what your performance is. If your performance is about very
Speed.
high latencies, very low latencies, very low high concurrent latencies, then this architecture makes sense. If you are okay with good, decent, varied latencies, but you need a lot of concurrent requests, this the one which Postgres and lot of microservices also works. But in that case, then the question comes in, why Erlang? You can write that small note in even Go or Python or JavaScript, Node.js also, right?
Right. So this approach is better for low latency.
Low latency, and if you want to have everything managed by Erlang itself, that Kubernetes, whatever you see, the Kubernetes scaling up, scaling down, the Postgres database in the back end. If you look at it, all these things are being done inside Erlang shell itself, right?
Yeah, yeah. That's the like very powerful thing that a language
Yeah.
can do this. Yeah.
So it's all your choice. If your team is all Erlang or all Elixir, then building such a thing with the cohesive Elixir with mnesia and things like that, it's a very lightweight thing which can perform really good without having extra systems. Otherwise, you would have a very big Postgres box which could do redundancy Postgres two boxes, and then you'll have two, three boxes in the middle layer with all those microservices, Kubernetes managing it, and then the load balancer. In this case, you'll just have one, two nodes of Elixir or Erlang with mnesia replicated within them, and it does the same job actually. But mind you, somebody has to know these intricacies of how this mnesia, Erlang, and distributedness works.
uh, with Nisha and Postgres, I had a question. So relational databases, we have so many features of how the data is linked and it's relational. There are foreign keys, indexes. We have complex queries and constraints on the database. So I doubt if does how does Nisha plays out with all these things? If my data is relational and there are constraints that I have on it, so can we express the same thing with Nisha?
You can actually. That's what I do in Tivan also. I have foreign key references. I manage that in Tivan. I wrote a layer on top of Nisha, which is Tivan, which does this foreign key checks, foreign key references, and then it picks up it queries two, three tables and combines into a single one and then gives the thing. The thing about why Postgres and Nisha is purely an architectural choice. If Postgres is fine with you, let's say if you have a Postgres and then you have a similar system with Erlang and Nisha, and then you have a Erlang and then Postgres. Just say, think about this. Then let's think about a web request which is landing on the Nisha, which is doing its job with landing on Erlang with Nisha. It's doing its job by talking to Nisha, picking up the things and sending it. There's very, very less latency there to just do it. But in, let's say there's an Erlang node and then there's a Postgres. When the such a request falls onto the this Erlang node, it has to then send it to Postgres through a an SQL interface. It has to pick up the data, which is not actually an Erlang native data. It's a flat structure of it. Then it has to first take that thing, transform into Erlang term, do the processing, and then send it. So there'll be definitely be an latency overhead on top of that. In terms of just plain thing that you use, if let's say you have a good Erlang team and if you need a service as a moderately loaded service, not really high performance, like doing 10,000 transactions or something like that, then yeah, even small and medium sized things using an Erlang niche embedded inside Erlang makes some sense there. But if you have a complex stable structure, but every complexity comes with rigidness. If you have a good complex system, you have good amount of rigidness. Nisha, when you write for whatever layer you write on top of that, whatever you design on top of that, it's designed for your own very specific case. And then you can add flexibility to it to grow seamlessly, easily, by adding more features, more things into that. If you can orchestrate those things, if you can bring the discipline into those things, then Nisha always rules there. because it's easy to do, it's more flexible. But if you have a Postgres table structure, if you, let's say you want to add one more field to it, it's a humongous change in database. You get the point?
Yeah. Mhm.
I agree. Yeah.
But at the same time, you have a complex structure, a big structure, and then you want multiple other systems to talk to. One main drawback with Nisha is that any other system querying Nisha is ruled out entirely. They all has to go through the web interface of this particular service.
Yeah. Like with traditional web applications, we have these SQL databases, and I see that they are like very complex relationships are there. There might be hundreds of tables and all sorts of relationships, and complex join queries with joining a bunch of tables, and doing some aggregate queries. And also I was wondering if that level of flexibility is there with this niche, like with Nishia. So yeah.
It's not there, but what I've seen over the years is that when people usually develop such a complex system and you actually look at what they're using, there's a huge difference.
Mhm.
And if you break down the use
So,
cases and see, it could actually be very simple table data structure actually.
so if I were to build a real-time bidding system, then I have very limited data. I can use Amnesia, right?
Yeah.
Because
We are
I don't
using,
have
I mean,
any
the current company, we do energy trading. The whole trading platform is built on Erlang with Nisha.
okay, because we have less tables.
Yeah. No, if you take my, one of the project that I did, which is CCS, which is cloud-based call center service, it's a huge, actually. We have 30 or 40 tables with even foreign key references, and it is a very, very complicated system. But it still uses Nisha and Erlang. There's no other database, just Nisha and Erlang. It
Okay,
is possible, but it's all about how do you design the use cases and then put it. But you should be really good at it. You should have good experience. Otherwise, I won't ask you to even bet on it. I have experience. I have confidence on doing that, so I do that.
okay. So, like, there is one library that Arpit had suggested.
Hmm.
Uh, Arpit, if you remember that library which you suggested me for making calls to ETS for caching.
CacheX, is it?
No, not caches. Okay, you continue. I'll get back in a minute.
Hey, most of you guys are in India or US?
Yeah. I'm in India actually. I'm in Pune. Sandesh is also in Pune.
Yeah, I know Sandesh is in Pune. Oh man, but it must be too late for you, right?
Yeah, it's midnight actually. 12.
Post midnight.
Yeah.
Oh god.
Yeah. No worries.
But just play around with Nisha in your time and then start writing code, see, look into the things and explore the things. You'll figure out that, for some
Mhm.
kind of situations you can actually use Nisha very well.
Actually, I started learning Erlang year back or something, but there is no consistency. I have to
Okay.
also work with my job. So in the meantime, whenever I get a free time, I look into the Erlang and I keep updated myself. Like some stuff I know about the Erlang, like syntax and the basic stuffs I know, like how it
That's
works.
good.
So, but the lack of experience, you will not get anything to work on it. So that's very bad
Yeah.
thing about Erlang.
Imagine doing
Yeah,
that in 2003 when you don't even find books even.
Yeah, it's really hard. Nowadays there are a lot of books, like
Yeah.
Francisco has a book, Joe's book.
When we 2003 when we started using Erlang, my company could manage to get half of the book The only book, there was only one book available, and they could manage to get only half of the book, and it
Oh,
didn't have OTP. For 5 years, we didn't use OTP.
oh my God. It's really tough.
Somebody came, somebody joined who had a good brain, and he saw the, Erlang documentation that there's something written called OTP, and then he figured it out and told us, "Hey, why are you writing all this nonsense? This is already written in the form of OTP."
Okay. Okay. We have this thing called Nebulex, and it has wrappers for ETS. I will check
Okay,
if it has wrappers for this also. For
okay,
yeah, amnesia. I need to check. But for ETS it has. So
okay.
it makes it easier for us to write Elixir code, regular Elixir code, and yeah, it makes some
Awesome.
magic easier. Yeah, Abhishek, we need to check it sometime. Nebulex with amnesia.
Can you post the link of something?
No, we need
Name
to Google it. Nebulex with okay,
Nebulous. Okay.
yeah. Uh, okay, we had a lot of time, and I think we should close in maximum 6 minutes. If there are any questions, because it is late for us, and
Yeah, it is. Yeah, we can talk sometime again later on.
Definitely.
like, yeah, if anyone has questions and wants to reach to Chaitanya in future, Chaitanya, what would be recommended way?
Um, yeah, Twitter it could be one, but I would suggest using this Gmail address.
Yeah, uh, Gmail.
Yeah, I can put it here in the
Yes.
chat.
Okay.
I just want to thank Chaitanya for coming in. This was very, very informative for me. I had like zero idea of amnesia and not much idea of distributed programming. So this was very informative. Thank you.
You're welcome.
Pink
That's
was
great.
nice.
Yeah.
Even I wanted to thank you, Chaitanya, and this Sriram is going to thank you personally. He had to leave for some reason,
Okay,
but
no
he will
problem.
contact you. He
Okay,
left a message with me for it. Okay.
great.
Mm.
Thanks, Chaitanya. It is a very nice talk, and it it gives me a improvement in my knowledge in the journey of Erlang.
Great, good. Glad that it's been useful.
We
Definitely.
Yes, a
we
lot.
were all,
Yeah.
and suffice to say, we were all hungry for this. So you came at the right time.
Yeah, because the resource you will not get easily. Like you read the books, but
Yeah,
you don't get the concepts within the books. Like someone has to explain you. Otherwise, just you can read and you just go away.
Totally agree.
Someone has to
Totally
explain.
agree.
yeah. I'd be glad if anyone even in this team actually can explain to me Phoenix very well. I really don't know what it is.
Okay. We will do some effort. We will all will
Great,
thank you with
thanks.
it. Yes. Next Friday we have a similar talk with a Scala expert,
Oh, good.
uh, and he's coming to Elixir, this Elixir community, and I said you have knowledge of Scala, Akka framework and all,
Mhm.
and actor model. If you can help us explain the difference between both and more technically around it, and he has
Yeah,
agreed to it. So
great.
he was about to attend this meet, but something came up and he messaged me today morning itself that man, I won't be able to attend today, but he is
Okay,
eager to watch the recording.
awesome.
Yeah,
I'm glad. I'll try to attend the for next Friday. Yeah.
Scala one. Yeah, he's also
Yeah.
some 20 years experience, 20 years
Mm,
of coding experience.
okay. Awesome.
Okay. Okay, if there are no more questions, are we good to take a stop? Arpan,
Yep.
Satish, Abhishek.
Yeah, I'm good.
Mhm. Yeah.
Yep.
Okay, thank
Nice
you,
meeting
everyone.
you all, guys.
Thanks,
Bye bye.
Chaitanya.
Thanks a lot.
Chaitanya, I will post this on YouTube some other time, and I will
Okay.
connect you personally to ask what should be the talk title and all. I will connect with you. Okay,
Okay. Sure.
thank you, man.
Yep.
Yeah.
Thanks.
Thank you, everyone. Good night.
Thank you. Bye, guys.